Okay, let's talk about the area of rhombi of a rhombus. Still have difficulty calling multiple rhombi. Okay, rhombi. The area of a rhombi is 1/2 times d1 times d2, or d1 times d2 divided by 2, whichever one you want. Now d1 is first diagonal, whichever one you want that to be. d2 is the second diagonal. So we're looking at the length of the diagonals, product of the diagonals divided by 2. Okay? All right? We're going to prove this and look at this, and we're going to do it a little bit different. I've got a rhombus right here. Look at that, and let's see how it is. Basically, I've got a diagonal here. What do we know about a rhombus? We know that all the sides are equal. We know that, I didn't even mark it on there, but we know that the diagonals meet how? Right angle, perpendicular to each other. We also know that they bisect each other. Why? Because a rhombus is a parallelogram, falls into the family of parallelograms. Remember that Venn diagram? Pull it out and look at it. Okay, so basically 1/2 of that diagonal equals the other half of the diagonal, so forth and so on. So these two pieces are equal to each other, these two pieces are equal to each other. We're going to call this A, and that's A also. We're going to call that B and that B. We're going to call this triangle 1, triangle 2, triangle 3, triangle 4. And we're going to come over here and say, wow, D1 equals A plus A. Dun-dun-dun. D1 equals 2A. Let's solve for A. A equals D1 divided by 2. And do the same thing for B, and we come up with B equals D2 divided by 2. Now look at that very carefully. All we're doing is doing algebra. Why am I pushing algebra so much? Because we're at the end of geometry honors. You're going into either pre-cal honors, or you're going into college algebra, or you're going into, those higher levels. At least here at Decatur you are. Other places you're going to be going into algebra 2. And you're expected to know how to manipulate equations. If you cannot manipulate equations in your head and put that down on paper, you're going to be lost like a little puppy at rush hour in downtown Dallas. And your opportunity to become squished like that little puppy is going to be high. Run away, go like, Mama, I don't know what's going on. Okay? If you're not understanding this, find somebody who can explain it to you. I'll be glad to. And get this done. But all we're doing is we're just manipulating this thing. You got to know the characteristics of a rhombus in order to make this happen. So this is what we are. So we can look at this and say, wow, the area of a rhombus is just, wow, the area of triangle 1 plus the area of triangle 2 plus the area of triangle 3 plus the area of triangle 4. And that's all we're doing there. Okay? Taking the sum of the 4 areas of those triangles, and we're going to add them together, and that's going to be the area of that rhombus. Is that a way to do that? Yeah, you can do that. That works. Now, let's look at that. The base is A, height to B. Base A, height to B. A times B divided by 2. 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 I got 4 of those things. 4 times AB divided by 2. Well, if I factor that, I got 2AB. Okay, so basically we're looking at 2AB. Okay, now what do we know A is? Go back over here. A equals what? Half of D1. What's B? Half of D2. So let's take our equation for the, I guess that really is a rhombus since we're only doing one, isn't it? Let's correct that then. Okay, rhombus. Okay, 2AB. That's 2 times, we got 2 things that are equal to each other. We can use either one. D1 divided by 2 times D2 divided by 2 equals what? We can multiply the bottom together and multiply the top together. We got 2 times quantity. D1 times D2 divided by 4. Factor out, what do we have? D1 times D2 divided by 2. Look at there. We took the area of 4 triangles, using the triangles, area of the triangle, added them together, using the characteristics of a rhombus, prove that this right here is those four triangles added together. Okay? Now, why did I do that? Simply because I wanted to tie it to something you already knew. Simply to help you understand there are multiple ways for you to find the area of rhombi. You can take all those triangles you got. All those four triangles are congruent to each other. Find the area of one of them, multiply times 4. Oh, divide it in half. Take one of those diagonals, divide it in half. Find the area of half of that thing and multiply by 2. Got it? Multiple ways. That's just a bunch of triangles. And what is this equation they give you? It's a way to combine those triangles using one formula that works. It's not something brand new. It's something that's there based upon what you already know about rhombi. Let's do some examples. Okay, we've got some examples of some rhombi that we've calculated the area of to. Fairly simple, straightforward. Again, these can get complicated depending upon the trigonometric ratios you need to do. I expect that you know how to do that, and you can. Alright, so let's look at the first one. We've got a rhombus here who has, let's mark it up so we know it's a rhombus. Okay, those are equal, which means it's a rhombus, parallelogram, rhombus. Diagonals bisect each other, they meet at perpendicular to each other, all of that good stuff. So what's D1? Well, I chose D1 to be 20 plus 20. Add those two pieces together. The total of that diagonal is 40. D2 is 10 plus 10. The total of that diagonal is 20. What's the equation? There it is. Product of the two diagonals divided by 2. Do that, you get 400. Rather straightforward and simple example there. Now let's look at this one. You're given what's in blue. Those of you that are colorblind, I apologize. You have a rhombus, all the sides are 12. You're given that this angle right here is 60. What does that automatically make this one up here? Makes it 30. Wow, those are all 30, 60, 90 right triangles. All four of them are. Okay? So if I find out what this side is, I know what that side is. I find out what this side is, I know what that side is. Because all the sides are congruent, I know that this side is 12. The side across from the 30-degree angle is going to be half of the hypotenuse. The hypotenuse is 12, therefore the side across from the 30 of that special right triangle, 30, 60, 90 right triangle, is going to be half of the hypotenuse. So this side is going to be 6. Well, that means this is 6. What is the side across from the 60 going to be? It's going to be the short side times the square root of 3. So 6 times the square root of 3. So D1 I chose to be 6 plus 6. Add those two together, I get 12. D2 is 6 square roots of 3 plus 6 square roots of 3, which is 12 square roots of 3. I'm leaving it just like that. I've got 12, which is D1, times 12 square roots of 3, which is D2, all divided by 2. Do that arithmetic and you get 124.71. So on this one we had to know about special right triangles, or we would have to use trigonometric ratios to get that. Okay? Now, I cannot emphasize enough, going into your next higher level math course and up above, those of you going into careers that are going to use high level math in college, you're expected to know these equations. Okay? It would not be unusual in your physics classes, in your calculus classes, for you to be asked to get the derivatives of these equations. And you just have to know what they are. Otherwise, you may know how to do the calculus, but if you don't know the equation, you are sure out of luck. And that's not a place you want to be in. So, get these down, memorize them. Got questions? You know where I am.